All right, so I have a vector here that goes from the point 3, 2 to 5, 6, and I have some point out here. What is this point? 1, 2, 3, 4, 5, 6, 7, 4. And we're trying to come up with a vector. Let's see. I'm trying to find another point so that that they'll connect. Let's call this this is A, B, and this is point C. We're trying to find, say, a point D that will make that C to D perpendicular to AB. The thing we have to remember is that when two lines are perpendicular, their slopes are negative reciprocals, which means that they multiply together to make a -1. But normally we think of negative reciprocals just as upside down negative versions of each other. So the slope of this line here, slope of vector AB, is 4 over 2, which reduces to 2 over 1, or just 2. So the slope of CD needs to be negative 1 over 2. So flip it upside down and change its sign. So let's see. That would be down 1 and over 2. So we could pick this point right here, for example. So this vector, right? So this could be point D. That would be the point 9, 3. So that would work as a possible point D. But there's lots of others. I could go down a little further. All right? That would also still be perpendicular. If I made this point D, call that D1, I'll call this D2. In fact, I can go down a little bit further, like that. All right? Call this D3 down here. All right? Still perpendicular. Or I go in the other direction. Say up here. Right? All the way out there. Call this D4. All right? Any of those. In fact, any point doesn't even have to be a lattice point. I could pick any point on that line, and the vector that goes from C to that point will be perpendicular to the original, because its slope will always be that 1/2, or -1/2, the negative reciprocal of the original. And I could describe all those points using the equation of that line. And if I need to write the equation of the line, we can use our point slope form, which is y equals mx minus h plus k, where h and k is just some point that the line passes through, and m is the slope. Well, we know the slope, it's -1/2. And we know the point, it was point C. So x minus 7 plus 4. And I could simplify that into slope-intercept form by going, let's see, distributive property gives us -1/2 x plus 7 over 2 plus 4. Let's see, 4 is 8 over 2, so it's 15 over 2 when you add it all together, which is 7.5. And let's look here. 1, 2, 3, 4, 5, 6, 7.5. So that adds up. Our y-intercept is 7.5. Okay, so there we are in our slope-intercept form. So again, the thing to remember, your takeaway, is that the slopes of perpendicular lines are negative reciprocals. The easy way to find negative reciprocals is just take the slopes, just flip it upside down, and change the sign. And keeping in mind that, 2 flipped upside down is 1/2. And then, if we want to write the equation for a line that's perpendicular, and we know the point, we know the slope, we can use our point slope form, where m is the slope, and the point is hk. Notice that's minus h and plus k. So just fill in the blanks. There's the slope, and there's the point, and we can simplify it to slope-intercept form. And that sometimes helps verify. So we don't have an exact intercept up here, but it's in the right neighborhood, so I've probably done my math correctly.